Welcome to solverfy.
We'll be considering more problems on friction. Consider the case where a woman on the high plane is trying to lift a boy from down below. What we can do to solve this problem is to apply friction principles, equilibrium, as well as the belt pulley relation. Now, let's say T1 is the tight side from the diagram there, okay, where the woman is, tight side, okay, of the rope, the string, and T2 is the slack side where the boy is. So T1 relation, T2 is going to be T1, T2, E, okay, mu theta, where mu is given in the question, okay, the angle of the coefficient of friction between the string and the surface there. Okay. So when we plug in our values in there, we are going to have our T1 to be, of course, T2 is given is 100, is 100 IB is given in the question. So when you do that, your this one is given also 0.2. Then the angle of wrap there is 90 degree, okay, which is pi over 2. When you solve this out, you're going to arrive at T1 to be 136 IB. Okay. We can consider equilibrium in the vertical direction. If we do that, we are going to have, okay, to be equal to 0, so that the summation of the forces there, W is going down, is the weight of the woman plus the normal reaction, okay, there on the floor where the woman is standing, okay, so equal to 0. When we solve this, we are going to arrive at N. Since the weight of the woman is 185 IB, that means the weight of the woman is equal to W. So therefore, N is equal to 185 IB. Okay. Now, if we consider equilibrium in the horizontal direction, you're going to have this. Okay. So that the frictional force is going trying to impede motion in that direction, while the tension is T1 is positive, is equal to 0. Okay, so that we will now have our F to be equal to T when you do this, so that of course we know that our tension, we got our tension T1 to be equal to 136 IB. So therefore F is equal to 136. So the force, the minimum force is 136 IB. Okay. Okay. Now you can see that if we can even confirm this further by trying to get the maximum frictional force that could be available or that is available. Or, so if you do that, we know that mu times n will give us the frictional force, and the coefficient of friction there is given as 0.3. So if we solve this out, 0.3 between the floor and the feet of the woman, the floor, the ground. So times 185 IB that we got for n. So when you do that, you're going to arrive at uh, a value that is 148 IB. So you can see that the frictional resistance, if the force is more than enough, the force that is required to pull the man is enough, to pull the boy is enough. So it is possible for the woman to lift the boy.